most common reason that we would want to negate a polynomial is because we're about to subtract two polynomials. So when we want to subtract two polynomials, we remember that subtraction is adding the opposite. And so subtracting polynomials is the same as adding the first polynomial to the negation of the second. So we're going to go through this process once, justifying every step, and then we'll go through a couple of shorter ways of doing this. So after copying the given polynomial, I'm going to rewrite all of the subtraction as adding the opposite. And also note that the negative sign outside these parentheses represents a multiplication by -1. And so seeing that multiplication by -1 makes it clear that before we can get rid of the parentheses, we need to distribute. So each term in the second polynomial is now multiplied by -1. Now we'll actually do that multiplication. We'll have a -2x squared plus a -6x plus a +5. And at this point, we are now adding two polynomials. We can drop the parentheses with the associative property. And now this next step, we're combining the commutative and associative and distributive properties to combine like terms. Not showing all the gory details of this part of the process. But we have x squared terms. +3 plus -2 will have 1x squared. Plus, we have a -5x plus a -6x is going to be -11x. Plus, we have a +3 plus a +5. So that's going to be +8. And then our last step, we'll just tidy up, right? Get rid of the multiplication by -1. Adding -11 is the same as subtracting 11. And there we are. The result of the subtraction is just x squared minus 11x plus 8. Now again, we've written out 3 steps involved in turning that subtraction into addition, right? It's an application of the distributive property. It's multiplication by -1. Normally, we will not write all of these gory details. This is how we would typically write something like this. We would say, first we'll copy the given expression. We would say, I want to get rid of the parentheses. I have to distribute the negative sign. So all of the terms of my first polynomial stay the same, 5x squared minus 4xy minus 6y squared. All of the terms of my second polynomial get negated. So instead of a +3y squared, I have a -3y squared. Instead of a +3xy, I have a -3xy. And instead of a -4y squared, I have a +4y squared. So typically, the only step in this process that we'll actually write out is this one where we distribute the negative sign. And then we'll just combine the like terms. So we've got a 5x squared. Oh, and that's it. That's our only x squared term. We have a -4xy and a -3xy. Those combine to be a -7xy. And then we have a -6y squared, a -3y squared, and a +4y squared. So we're thinking -6 minus 3 plus 4, that's -5 minus 5y squared. So the only step in this that we wrote out was the one where we distributed the negative sign. And there is an even shorter way of thinking about this. If you're comfortable doing subtraction involving negative numbers. So if we have this subtraction of polynomials, 5x squared minus 6x plus 3 minus 2x squared plus 3x minus 3, we can think, I'm going to combine like terms using subtraction. So I'm thinking 5x squared minus 2x squared. 5 minus 2 is 3, so I have 3x squared. Next, I'm going to think negative 6x minus 3x. Negative 6 minus 3 is negative 9, so I'll have negative 9x. And then I'm thinking 3 minus negative 3 is 6, so I have plus 6. So at each step, I was just thinking subtraction. But at 2 of the steps, I had to do subtraction involving negative numbers. If you're comfortable thinking subtraction involving negative numbers, then when you're subtracting polynomials, you can think, I'm subtracting like terms, and work it this way. I would say that for something relatively simple like this, where I have a relatively small number of terms, I would be comfortable doing it this way. If I had a larger number of terms or more complicated things to keep track of, I would be more likely to write it this way. So this way if it seems easy, and this way if there's more to keep track of. You can use whichever method you like better. But if you find that you often make mistakes when you're subtracting with negative numbers, then this method might not be the best choice for you. This method will always get you there, and there's never anything wrong with writing out one extra step.